Welcome to solverfy.
In this case, we have four L3 by 3 by quarter inch angles welded to a rolled W section as shown. So we have this I-beam with these angles welded onto it to give it to strengthen it. And let's see here. We want to determine again the area moments and radii gyration of everything. So because of symmetry again, our centroid is going to be here, and because these are all the same, and because of symmetry, we can just look at one of them. So we have we need to look up all our properties for these different types of beams. And for the I-beam in the middle, we have that its area moment about its center of mass, or its centroid, is 110 inches to the fourth, and about the y-axis, it's 31.7 inches to the fourth, and it has an area of 9.12 inches squared. Now, these guys, because they're have the same height and length, their area moments about their centroid in the x and y directions are the same, and they're 1.23 inches. So its centroid is going to be something here, and because of symmetry about that axis, the x and y area moments will be the same. Now, they have an area of 1.44 inches. The centroidal axes for the whole section here goes through the centroidal axes of the I-beam in the middle, so that we just get the centroidal area moments for the whole cross section is the same for the centroidal moments for this I-beam, so we don't have to shift it anywhere with the parallel axis theorem. Now, for these guys, we do have to shift them because its area moment its centroid is somewhere around here, and we need to shift it back to here. So we get its centroidal area moment about the x-axis plus its area times 4 inches, because this distance from the top of this flange to its middle is 4 inches. And then we get plus 0.836 inches, because that's how far from the bottom of this flange here is that this angle here is to its centroid. So that the total distance from here up to here is this value. And so we get that the area moment of this thing about this axis is 34.91 inches to the fourth. And we need to look at the y-axis. And we can again say that, okay, this we're told that from here to the outside of this was 5 inches, and so then we need to come back this 0.836 inches, and so we get a total area moment about this y-axis of 26.20 inches to the fourth. So it's going to provide, these things are going to provide significant strength by significantly increasing the area moments of this cross section. Now, if we just look at symmetry, we can figure out that all of these are going to have the same area moments about the x and the y axes. If we actually were just to try to calculate this, you'd see that again, because these things are squared and symmetry, we will get the same values for all four of them. So we can just multiply it by 4. And so we get a total area moment about the x-axis of about 250 inches to the fourth, and about the y-axis is about 142 inches to the fourth. So we can see that it significantly increased the area moments of just this I-beam. So we made it a lot stronger. To get the radii of gyration, we can figure out the total area. So we have the area of these two, and so we need to take 4 of these and get our total area. And then we can then calculate our radii of gyration with all that information, and that about the x-axis becomes 4.10 inches, and about the y becomes 3.09 inches.